Hello YouTube, RJ. Well, I did an unboxing on my 4090C LCR meter, and I thought now that I've been using it for about a month that maybe it'd be a good time to do a review. Now that I've learned to use it, I've learned its in and outs a little bit. I can talk a little about the quality and what I think of it and such. Basically show you some of the benefits of LCR, why you might need one. So this is the Ruoshui. I'm not sure exactly how to pronounce this. Ruoshui 4090C 100K LCR meter. And I've kind of set up here to do the very first thing I wanted to show, and that was that I've got my little O1 meter out here, and I want to show you that a lot of people say, well, why do you need, LCR, inductance L, capacitance C, resistance R? Why do you need another resistance meter? You've already got one, you got multiple of them in your multimeters. And so I thought I'd show a little demonstration of that. And if you can see over here, you really can. Let me pull it over maybe. I've kind of brought the cameras up close where you can see decent. I've got this meter and this meter shorted, and I've got them both on resistance, and you can see this is zeroed out. This is pretty close. Let me try to do a relative here and get the leads zeroed out. Okay, close as I can get. Okay, so I've got a 1% 2 ohm resistor here. Okay, now you would expect if I was to take my digital multimeter on resistance scale and I would to hook this here, you would expect to see somewhere, being a 1%, somewhere pretty close to 2 ohms as a resistance. And you might notice that not so much. So maybe we can get a little better here. Maybe we get rid of these. There's going to be resistance in these little clamps. So let's take the clips off. Let's re-zero the meter like this. Calm down a second, and we'll zero it. Okay. And let's see what we get if we do the old finger hold it to the resistor. It's kind of moving around on me here. 1.6, 1.7, sometimes bouncing over 2. Doesn't seem to be that stable for some reason. It's all over the place. What's going on? 1.2, 1.09. Well, that's interesting. So let's take a look at what if we instead put it on the LCR meter in resistance mode. What do we see? 1.994746. You can probably pick up quite a difference there. What you'll find with your digital multimeters is some are better than others. I'll grant you that. I don't want to, this is not a high-end multimeter here, but it works perfectly fine normally. The problem all has to do with we're measuring a small resistance. And when you get into small resistance, you get in a lot of problems with your resistance in your multimeters. You've got lead resistance that causes issues. You have that you're trying to put the current through the resistor with the same set of leads, same conductor that you're trying to sense the voltage. So you get errors built in from that. So when you go to an LCR meter, one of the things that you do is you get away from that by going to Kelvin clips. So each clip has 2 leads, a sense and a force. And so you put the current, think about testing resistance of a resistor or anything. What do? You apply a certain amount of current to it and you measure the voltage difference across it. So you've got to flow current through it and then measure the voltage drop across it and calculate from that, Ohm's law, to figure out what is the resistance you're working with. So imagine now that you're doing that, but with a multimeter, leads with single conductors, you have to put the current through the same leads. The resistance in those leads are going to create a voltage drop. So the more current runs through, the more error you're going to create into your measurement. Well, at low resistance, you're going to have the current being pushed through, you're going to see enough of an error pile up that you see all kinds of error built in. And like, you cannot measure 1% resistors very well with a digital multimeter if they're 1 ohm or under 1 ohm. So LCRs come in there. They're very good at doing that because they put the current through one conductor and then they sense from the other. So you do not have the resistance of the lead having current flowing through it. The sense lead is such a high impedance that there's no real return current. So there's current isn't going, no current, no voltage drop. So you don't creep those errors in. So right off the bat, one of the things with an LCR is you're going to get much better low resistance measurements. So that's the reason that an LCR has resistance built into it. Now, let's talk about the meter. Step one, how long does it take to come on? Okay, it's very quick to boot. It's already up. So a Pro for it boots up really fast. I like how's the build. I like the build for the price range. I think it's great. I think I said in my unboxing video that basically it's not an Agilent, you know, it's not a fluke. It's not, but it's really a solid build. I mean, you have nothing to really complain about. One of the complaints I've seen listed is the frequency button says FREG, okay, instead of FREQ. You know, one of those Chinese translation issues. Does it bother me? Not really. I know that's the frequency button. I've seen people that, I actually saw one commenter that returned his because of that. He said he just wasn't going to put up with that. To me, it doesn't bother me. I understand that I'm not buying the highest end meter, but I'm also not paying the highest end price. So, you know, it allows me to afford something I need in a good, decent quality, so I can put up with little things like that. As far as the operation of the meter, we'll test a few devices here to give you a run through on it. I'm happy with it. Of all the things that I can complain about is it comes with a European plug instead of an American plug. So if you're you know, if you're USA and you're needing a USA cable, make sure you have a plug. It uses the universal connector to the box, but you've got to change the cord out. You're not going to get. I ordered it from Amazon, and even from Amazon, the same thing happened. That's one minor little complaint I have. Number two, really the only other complaint I can have with it is it's a little slow to calibrate. But I understand that typically you don't have to calibrate these things that often. But I have a little bit of a different situation where I use my thermal test cell over here to test stuff. So I'm often hooking this to pass-throughs that have their own cables inside the box. So that means when I hook this up, I've got to calibrate for it. And then when I come off of that, I'm going to use it on the bench, I've got to calibrate it for this. So I do tend to calibrate quite a bit. And the problem with calibration is the speed. It comes up and gives you a 20 count for both the open and closed calibration, but that's not seconds. It takes about 45 seconds each one of them to run through. So I'll give you a demo of that at the end of the video. That way I can run through and time lapse it where you don't have to sit and watch the whole thing. But you're basically looking at about 1.5 to 2 minutes to calibrate this to get it ready to go if you change anything. Now, most people, that's not going to be a big deal. Calibration simple. You leave the probes, the Kelvin clips, you know, open. Hold calibration for a few seconds and it'll run through and do an open. It recognizes they're disconnected. You short them, you do the same thing. It recognizes that they're shorted and it'll run a shorted calibration, and then you're good to go. So it's not hard to do, just takes a couple minutes. Other than that, a couple things that got me that's not their fault, but is it has a capacitor symbol right here. If you can see, if I get my big fat fingers out of the way, little capacitor symbol here. I kept hitting that to do capacitors, and I was doing, you know, ceramic capacitors and stuff, and I was having some weird, you know, things happening, readings that didn't make sense. I started to question whether this thing was working right. Well, it was my mistake. Turns out that is used for electrolytic capacitors. If you're doing any others, you don't use that button. That button is when you're going to test electrolytics. They it changes a little how the meter works. So only hit this when you're going to do electrolytic capacitor. The rest of them, you just go into you change into the function. You can probably see the function here is RS, resistance serial -X, meaning that it's going to give me serial resistance and X. I can rotate through these. This button up here, the auto/R/C/L/Z, rotates my main reading through the different types of readings. Okay. The button below that, marked XDQ ESR, rotates you through those readings down here, so you can choose what you want for your second display. Here's your quality, here's your theta, there's ESR. So we can rotate either one of these through using these buttons. So to do capacitors, you'd have to decide whether you want serial or parallel. So I'm on resistance serial at the moment. If I wanted to do parallel, if I was doing a resistor, well, not so much on resistance, but here I'm doing a capacitor serial. Depending on the size of your capacitor, you'll use serial or use parallel. I'm not going to go into that. There's a lot of information available on the web and on YouTube that'll explain when to use one and the other. The little manual will go through. It's usually basically a split of the size of the capacitor that you're measuring. If you want to go to parallel, over here, you'll see auto, serial, parallel. There's parallel, there's serial. Okay. To measure, so now we're set up to measure a capacitor. So if I was to take, let's use one of these ceramics here. If I take one of these little ceramics and hook it up, let's see what it is. $786 nanofarad. Okay, let's do another one. This should be a different size. I can just randomly grab this out of the junk box. There's a 10 puff, 10.15 puff roughly. Okay, it's that simple. It measures capacitance much more accurate than my little cheap. I have a little cheap capacitor meter here. I'll give you a quick look of, and it works, but I found it to be not exactly real accurate in a lot of cases. The LCR is so much more accurate that if you're going to be doing RF or oscillators or something where the capacitance needs to be, you need to know exactly what it is, and LCR comes in absolutely necessary. Now, let's say we're going to do electrolytic capacitors. Okay, that's where we would reach over and hit the capacitor symbol here. And now we're ready to do this. Always make sure you discharge these. There's nothing on them. Always hook your connectors up correctly. Big capacitor like this takes a moment to settle out because it has to charge the capacitor to some point. That's reading pretty close to 4.1 millifarad. Okay, it's a 47. Let's try this again. Let's change our frequency. This is where frequency comes in. I was on 1 kilohertz. Let's go down to 120 hertz. Why? Because that's where they measure these types of capacitors. And it's coming up about 4.3, so that would be 4,300 microfarad. This is a 47, but it's a 20% capacitor, so that falls within the range. So let's go down to a smaller one. Here's a 1,000. Let's see how that works. Right within the 20%. If you get down to something small like this 0.1, you'll notice that the speed for it to get there, give you an accurate reading, is much quicker. It doesn't have as much charging to do on the capacitor. 97 nanofarad. This is supposed to be a 0.1 microfarad, so that would be pretty close to dead on. way within the 20%. So that's all great, and that's very helpful, and I use the capacitance a lot. I've used the resistance some, but the main thing I purchased this for my lab was because I do RF stuff, and I'm using inductors, homemade inductors, and I needed an accurate way to measure them. So that's where this is where this thing comes in to be worth its weight in gold to me. I'm going to go up here and change to serial inductance, and I'm going to hook up an inductor here. It doesn't matter which direction. And we can see that we're running about 478 microhenries, which is just about dead what it should have been. This is a different core, going to be much higher inductance. Let's see what we come up with. Yeah, about what I thought, roughly 50 microhenries. So that's how it works. Now there's a couple other things. Speed. Notice how it's updating. That's on the slow speed. If I put it on the fast, it will update at a much faster rate. Give you an example of that hooked up. Much faster update if you need it. You've got a mid-range and you've got a slow. To me, I like the slow speed simply because it doesn't flicker so much. It doesn't change so rapidly. On top of that, you've got a range. Currently, it's in auto. It's just automatically adjusting. But just like a multimeter, I can go into range and I can tell it to lock. I can set the range and tell it to lock. The other thing that you can do is the level. Currently testing these capacitors and stuff, it's using 1 volt to do so, but I can hit level and using the arrows, change it. There's 600 millivolts. We can go down to 100 millivolts and as high as 2 volts. So the default's 1 volt, but you can choose that. You can decide that I need more voltage in for testing this component. You can adjust bias voltage if you have a need for that. There are statisticals. For example, if I hook up, let's hook our inductor back up since we're set up on that right now. Okay. If I go in and hit average, down here, if you can read it, it reads average microhenry 50.307, and it's averaging the readings. But if I wanted the max, I can hit max, and now it's doing the same thing with the max. It's giving me the max it has seen. I can use minimum, it'll give me the minimum it's seen. So some statistical stuff on whatever you're reading. That works on resistance, inductors, capacitors, doesn't matter. The other thing you can do is you can set up compare, where you can put one device under test, disconnect and hook to another device, and it will compare the two and give you the differences. That's the compare button over here. It'll give you the differences of the two to tell you how much they vary. You can set up pass-fail, so you can put tolerance levels in and have it give you a pass-fail when it's testing things. So that's all kind of neat. You can also hold. As you see, it's changing. Let me put it on fast where it's really apparent. If I wanted to lock the reading, I can hit hold and it'll freeze, just like most multimeters. Hit hold again, it goes right back to life. Now, I've told you 2 things I didn't like. I didn't like getting a non-American plug. I don't like that it takes so long to calibrate. So what else do I not like about it? Honestly, really nothing. Everything about it's been good. When you consider the price point of this device, I think it's a bargain. I was looking at an East Tester 4410, which is East Tester's 100 kilohertz LCR. It looks almost identical to this. Their button is round red. The little red right here around these buttons is not there. Other than that, it basically looks identical. Another YouTuber pulled this apart, and the board that's in this unit says East Tester 4410 on it. So this is just a rebadged, little bit of color added here, renamed, rebadged East Tester. The difference is this is over $100 less if you purchase this over the East Tester. So that's the reason I went with this over the East Tester. Very, very happy. The arm, by the way, works good. I keep it folded back because I keep it on the shelf. But for filming here, it showed up better in the camera without glare with the arm down and tilted up. There is a earth safety ground here if you need it for your particular setup. Everything about this works great. I really have no complaints. If you need an LCR, there are handhelds that are cheaper, not a lot cheaper if you get a good one. If you want one for your bench where you don't need to worry about batteries and you want to, this is definitely the way to go. I'm very happy with this purchase. Now, I'm going to quickly do a calibration just to let you see how that goes. And I'll let you watch it for just a few seconds, and then I'll do a fast, I'll speed through it. But let's do a shorted. Put my plugs together shorted. Try to. Calibration just requires you to push the cal button and hold it for a few seconds. You can see it goes to calibration. It says I'm shorted, which you are. It starts a 20 countdown. And now we're going to be waiting about 40 to 45 seconds for that to complete. Okay, that's it calibrated short. You can do an open the same way. Last thing I want to talk about on this before we close out the video is the connectivity. It has COM port on the back included with also with USB. I use that. It uses Skippy. Very easy to program too. I wrote some Python software that integrates many of my pieces of equipment here so that when I want to do testing with my thermal test cell, I can automatically control the temperature and log everything. I use this all the time with it. I put capacitors in there, I put variable capacitors, I put inductors, I put oscillators in there, and I run up the temperature and log exactly the changes that I see. So this comes in very, very handy for that. It's really easy to use. It shows up on your computer as a COM port. Basically, you open a COM port and send Skippy commands. It replies back with the information. Found it very easy to program to. It's almost identical to doing an O1 or, my Siglent arbitrary waveform generator. It works very simple. It was easy to program to. Very happy how it works. Very happy with the whole thing. I think it's a good buy. Only comes with the probes and a couple extra fuses for it, and a European cable, power cable. So I like the clips. They're pretty solid. I mean, they're not HP Agilent type level, but they're perfectly good for my lab. So hopefully this was informative. Hopefully you enjoyed it. Please feel free to subscribe or like if you enjoyed the video. Thank you for watching.